Welcome to a lesson with Dr. Powell. Let's take a look at a computation of a limit. Namely, let's take the limit as x approaches 0 of 1 over x plus 1 minus 1 all over x. Notice that we can't just simply plug in 0, but we could maybe do some algebra and algebraically get an equivalence where the domain changes where we can plug in 0. But let's look behind the scenes of what's happening with limit properties. What if we were to think of just multiplying by 1? Now let's think about this 1 in a different way. This 1 actually can be rewritten as the limit as x approaches 0 of x plus 1 over x plus 1. Now, of course, you can plug in 0 here, so that's pretty clear that that's what that limit is, right? So pretty clear we can do that. This is what the limit is. This is equal to 1. But the beauty of doing that is that the limit is on the inside of the multiplication to both parts of the multiplication, and it can pass out freely because multiplication is a continuous operation. So the limit can come out. And then we're left with the following: minus 1 over x times x plus 1 over x plus 1. So behind the scenes, we're really using limit ideas of how to evaluate, and continuous things are the same as plugging in and going out. And then here we can really just, we can multiply this through to see what this is equal to algebraically, because if we maintain things equaling algebraically, it also maintains the limit, even if the domain happens to change. And so we proceed here, and we multiply through, and we end up getting limit as x approaches 0 of, now this will distribute in to here and to here, leaving us with 1 minus quantity x plus 1 on the top, all over x times x plus 1 on the bottom. Now, we can't plug in 0 yet, but look what happens to the top. We get 1 minus x minus 1. The 1's cancel, and we're left with negative x on the top. Negative x over x times x plus 1. And then now we can take a limit as x approaches 0. And notice those cancel, and which is fine for an algebraic type equivalence. We can get that cancellation. If we really wanted to, we could think of a limit property here, though. We could think of separating out the negative x over x times 1 over x plus 1. And then we're taking a limit across a multiplication, meaning the limit can freely pass to both parts. So now we can take the limit of this. Now, if we were to write that out, this is algebraically equal to y is equal to negative 1, except there's a hole right at 0. But we know what the limit is, because this is a continuous function up to that point. We just have to fill in the hole, and we fill it in at the y value at negative 1, meaning that this limit is actually negative 1. So we get negative 1 multiplied by this limit. And again, we can change forms, change this back into a limit, and then take the limit out of the multiplication and put it back in there. So essentially, we end up getting the limit as x approaches 0 of negative 1 over x plus 1. Then we can plug in 0 for x here now, because this is continuous now and defined. And so we can now plug in to compute our limit, and we end up getting negative 1 as our result. Thanks for watching.